In the last video that we did, we were looking at different types of inequalities, and there's one more special case of inequality that we want to actually look at. And it's what's called an absolute value inequality. And if we recall from earlier in the chapter, we solved absolute value equations when we had something like the absolute value of 2x plus 4 plus 5 is equal to 12, or something like that. And we went through how to solve those. Now, essentially, we want to change it into an inequality. So, if we remember, when this was an inequality, we said if the absolute value is kind of the new thing, the challenging thing, the thing that's confusing, we isolate that. It's causing a problem, so we isolate it. So we subtract the 5, we get the absolute value of 2x plus 4 is equal to 12 minus 5, 7. Once we isolate it, then if you remember, we said once you have the absolute value of x equals a, that means x equals a or x equals negative a. So for the purposes of this, 2x plus 4 equals 7, or 2x plus 4 equals negative 7. And then we solved both of those separately, and we got two solutions. And we also went over the graph, and the graph looked essentially like a V. And we said the rough idea was, if I want to know where the absolute value is equal to something, say 5, well, that's obviously at 5 and negative 5. But now, I know the numbers here on this problem are slightly different, but now, if I want to know where the absolute value of x is less than or equal to 5, well, these two endpoints still tell me where it's equal to 5. It's equal to something less than or equal to 5. I'm running out of colors here, but inside negative 5 to 5. If I want to know where the absolute value of x is greater than or equal to 5, well, graphically speaking, it's greater than 5 out on this end or out on that end over there. As far as it goes, you can either use the graph as a guide to how to solve the inequality out, or, much like there was a definition here, kind of based off of the graph, there's a definition we get out of this. If the absolute value of x is less than or equal to a, it means x has to be between negative a, I'm writing 5 because I have a 5 up there, negative a is less than or equal to x is less than or equal to a. So in this case, if the absolute value of x is less than or equal to 5, it means x is between negative 5 and 5, which is obvious from the graph. And then you just have a compound inequality to solve like we did in our last video. On the other side, if the absolute value of x is greater than or equal to a, well, if it's greater than a, there's really two possibilities. It's out here on the right or over there on the left. If it's out on the right, it means x is greater than or equal to a. If it's on the left, it means x is less than or equal to negative a. And again, like I said before, when we did absolute value equations, this was the definition which comes from the graph, and you have to know it and understand it and remember it so that you don't forget on your homework and on the exam. Same idea here. When we do absolute value inequalities, these are the two definitions. If the absolute value of x is less than or equal to a, negative a is less than or equal to x is less than or equal to a. Or if the absolute value of x is greater than or equal to a, x is greater than or equal to a or less than or equal to negative a. You can think about them graphically, or you just have to remember these definitions so you can solve the problems. So over here, we're going to go back to the beginning, but we'll change it to an inequality. Absolute value of 2x plus 4 plus 5 is less than or equal to 12. We start by doing the same thing, isolating the absolute value. So the absolute value of 2x plus 4 is less than or equal to 7. Once we have the absolute value isolated, now we use the definition. the absolute value of something less than or equal to A means negative A, negative 7 in this case, is less than or equal to, whatever's inside the absolute value, is less than or equal to positive 7. And then we just solve the compound inequality. I want to isolate the x, so I subtract 4 from all three. Negative 7 minus 4 is negative 11, is less than or equal to 2x, is less than or equal to 7 minus 4, 3. I want to isolate the x, so I divide the 2. Negative 11 halves is less than or equal to x, is less than or equal to 3 halves. And there's my solution. I get the closed interval, negative 11 halves to positive 3 halves. We're going to look at one more. Again, these ultimately boil down to knowing the definitions and then being able to do the algebra, and I'm convinced all of you guys can do the algebra, but I want to go through one more just so we're clear. So suppose I have 3 times the absolute value of 2x minus 1 minus 4 is greater than or equal to 5. Again, I have an absolute value, so I isolate it. I add the 4. 3 times the absolute value of 2x minus 1 is greater than or equal to 5 plus 4, 9. I still want to isolate the absolute value, so I divide the 3. So the absolute value of 2x minus 1 is greater than or equal to 9 divided by 3, which is 3. Now I have the absolute value by itself is greater than or equal to a. Remember, now I get two separate solutions. 2x minus 1 is greater than or equal to 3, or 2x minus 1 is less than or equal to negative 3. And then I solve those separately. Add the 1 here. 2x is greater than or equal to 4. Divide the 2. X is greater than or equal to 2. Add the 1 here. 2x is less than or equal to negative 3 plus 1, which is negative 2. Divide the 2. X is less than or equal to negative 1. And again, the key point here is, for this inequality over here, I get one interval. If you think about the absolute value graph, you get the stuff in the middle, one solid interval. Here, for the greater than or equal to, I get two separate intervals, one on the left and one on the right. Which means, if I want to write this as interval notation, x is greater than or equal to 2, means closed, because that's a greater than or equal to, from 2 to infinity, or here, negative infinity to negative 1, closed, because again, that's less than or equal to. And those are separate. The tendency from a student perspective is to see something like this and then do, and this is hard for me to actually write because I have to write it wrong and I'm not good at writing things incorrectly, but writing something like x is greater than or equal to 2 and greater than or equal to negative 1, or going the other way, x is greater than or equal to 2 and less than or equal to negative 1, which also doesn't make sense because 2 is bigger than negative 1, so it has to go in the opposite direction. And that's the point. When you write these, just remember, when it's a greater than or equal to absolute value inequality, you will get two separate answers. Do not try to write them as one. Write them as two inequalities, write them as two intervals. If you did it on a number line, writing it as two separate rays, but you get two solutions, not one like this right here.